and get started. We're really going to finish off the last section, the normal distribution. And I tried to collect some data on, just so that we've got real data to work with. And let's get started then. And this is some data I collected on, it's not actually weights. Weights is here, it's heights. And let's do the first one. American males, their mean height, 69 inches, and their standard deviation is 2.9 inches. So, guys can do this if they're interested. Let's find the probability that your height is greater than or equal to some number, right? So this is, what's the probability that someone's height is greater than or equal to, and I'll put this number here. Now I'm going to put in my height, which is 5'6", but you could put in your height and you could find out, as I'm about to do, what percentage of Americans are taller than me, essentially. So let's just show you what we do. This is all done basically in salt. It kind of makes things relatively easy. So I pick distribution calculation, make sure it says normal. I'll put in the average height for American, 69 inches, that's an American male. The standard deviation is 2.9. And I want to know what percentage are greater than. If you want to find greater than, left-tailed or right-tailed or between, which one do you use if you want to find greater than?
Right-tailed.
Yeah, you're right. And what number do I want to find them greater than? I want to find greater than 66. And the answer I get is about 85. So that doesn't make me feel very tall, but I'm not particularly tall. 85% of Americans are taller than me. So you can put in your height and you can find out what percentage of Americans are taller than you. Now, if you want to do it, the women want to do it. Got the data for them. The mean height of a woman is 63.9 and their standard deviation. Did I say 2.9? No, I should put 2.5 till it's 2.5. And what's the probability that a woman has a height greater than or equal to 66? And if I go to that table and I change this number to be a mean of 63.9, and I'll change that standard deviation to the right one, and I make this number here 66, and the answer comes out as about 20%. So that, I think, is pretty conclusive evidence that males are taller than females. Does that seem reasonable? On average. Are they tall females? Sure. Are they short guys? Sure. But for a fixed comparison, would you agree that a height of 66 inches, 85% of Americans are taller than me? If I was a woman at that same height, only 20% of them would be taller than me. It's not earth-shattering, but it is interesting. Did you know, for instance, I just collected this for curiosity's sake. Do you know that Indian women The average height of them is 60.1. So human beings throughout the world, male or female, they differ in height. And human beings throughout the world between countries can even differ in height. Now, I don't think I'm being racial. I hope I'm not. If I say things like a typical Japanese person is probably smaller than a typical Norwegian person. Right? It is just what it is. And there's no, I hope there's no negative connotations to that. Shouldn't be, but it's true. I also collected some scary data on American males. Here it is here. Now, these numbers are in kilograms, so I'm going to convert them into pounds. In the year 2000, the government conducted a survey where they do lots of surveys. This one was on males 20 to 39 years old, and their average weight was 84.3 kilos, which I'm now turning into pounds. Their average weight was 180, we'll call it 185 pounds. Standard deviation was 19.8. They have been conducting this, the latest one I could find, but there's probably better ones, was in 2016 for the same group of people. Their average weight is, this is kilos, so 89.3 times 2.2 is now 196 pounds. And the standard deviation was much larger as well. What does that tell you about males in America over that basically 6-year period? If you compare
them, generally gotten heavier.
We have. Now, I've seen articles about obesity. Obesity, being overweight, that's all that means, is a big problem in America, isn't it? A lot of us are. I'm one of, included in that group, is definitely overweight. And this has been a trend that's been going on for the last decade. Has anybody heard COVID-19? And I don't mean the disease or the virus. COVID-19 is a nickname they give. They haven't got real good data on it, but it's probably true that a lot of people have gained 19 pounds over the 2 years that COVID's been going. So they called it COVID. You know, people would say, I've got the COVID-19. What they're saying is I've gained weight. Now, if you're a fit, healthy person running about, that might not be the case. And I'm not asking any of you to volunteer information like that. But for some of you, at least, isn't that probably true that you have gained weight over the last a couple of years? So this obesity thing, I think when they get the latest data out, it's going to be even worse. That's my guess. Now, if you look at this, couldn't we find things like what percentage of Americans are over 200 pounds? Or what percentage of Americans are under 150 pounds? And couldn't we do it for each of these groups? And because the means and the standard deviations are different, wouldn't there be an awful lot more? There'd be a lot of differences between those two, right? So I'm going to make up a story. Anybody who is over 200 pounds, I'm going to call them overweight. Made up the number, no bearing resemblance in reality. Let's find out what the probability of an American in the year 2000, what's the chances that they were overweight? So we're trying to find the chances that their weight was greater than 200. And let's find out what it would be in 2016. Do you expect there are going to be more people overweight here than there is here? Because that's what I suspect. Let's go and find it. This is the kind of analysis you could do. You know, if you get the mean and standard deviation and you know the thing's normal, you can calculate all sorts of things. Okay, so what percentage of Americans are likely to be overweight? Well, for the year 2000, it was 185. And that the standard deviation was 19.8. And we want to know what percentage of you are bigger than 200. And the answer came out as about 22%. So 22% of American males are overweight, at least in that year. 2016 is coming up now. The mean had increased here to 196, and the standard deviation was 30.8. And we want to know 200, and the answer, by just sheer fluke, I did not pick this. It's now 45%. So it's slightly under half of American males, according to my description of overweight, which is more than 200 pounds. So if you were writing an article, couldn't you use numbers like this to try and prove your conjecture? Hey, Americans, we're getting fat, guys. Look at here's some data to tell you. Right. If you just tell people means and standard deviations, don't they switch off? Yeah, it's a number. People lie with numbers all the time. If you say to them, 22% of Americans were overweight in the year 2000, and now it's grown to 45%, couldn't you have a good article like there's twice as many fat people in America as there was before, right? And, you know, make fun of them and do whatever it is you want to do in your particular newspaper article. If you're doing a research paper, if you want to prove something, you want to show evidence at least to prove something, isn't this the kind of thing that you might want to do a comparison? So we're really looking at this as comparing the same thing with two different groups. We go with that? Could do almost, if you tell me the mean and standard deviation, I could do almost any kind of check that I like. So I'm going to do one more pretend question where we get to do left, right, and the betweens and so on. And then there's one more thing I need to tell you about, which is called percentiles and how to calculate them. And that will be us. And then for whatever time we might have left at the end of that, we can talk about midterm. Okay. So let's let's say that I calculated, I found that the mean age of people who play golf is 35, and that their standard deviation is 5, right? So I've got a lot of data, and the average age of somebody who plays golf is 35, and their standard deviation for that group is 5. And I would like to know what's the probability that a person who plays golf age is greater than or equal to 60. I want the probability that they are less than 29. And I'd like to do the probability then that their age is between 30 and 41. Now, bear in mind, I made up these numbers. My gut feeling is that there's probably a lot of variation in golf. Don't a lot of young people play golf? I know isn't that the kind of sport that people retire like playing as well? So maybe the average age in reality could be a lot bigger. But we'll pretend this is Scotland, right? So you want to find these guys one last time. Let's go over to salt. If the average age was 35 and the standard deviation was 5, the probability that somebody who's over 60 plays golf, it's not a mistake, and it does happen, and I'm pretty sure it's going to happen in your homework. Do you see that little warning sign and then the answer 0? You see that? That is saying that this answer is virtually 0. So evidently, nobody in Scotland over 60 plays golf. The reason it puts that little warning sign is any answer that's less than 0.00001 is called 0. And it's just bringing that to your attention. Well, maybe I'll get better on the next one. And I want to find the age that they're less than. So left tail and less than 29. Yay, got a number. Chances that you play golf when you're less than 29 is about 11%, at least to 2 decimal places. And then if you want to do a between, so we want people older than 30, but younger than 41. And the answer for that is about 72%. Or 73 actually, if you round it up. Are you comfortable now that if you know the mean and standard deviation, you can answer any of those questions about what percentage of people are bigger, less, or between, right? Because really all I do is, don't I just change these two numbers? What do these two numbers become if the question says Z bigger than this, Z less than that? What's the mean and what's the standard deviation when it's Z scores? We did them yesterday. What's a Z scores mean and standard deviation?
0.
0 for the mean. And standard deviation?
1.
Right. Normal questions tell you the mean and standard deviation, right? The height is, the mean height is 40 and the standard deviation is 10. But when you see a Z score, they may not tell you the mean is 0 and 1. Because you should assume that it is, because it's a Z score. So, what's the last thing that we need to do? Well, we need to find things called percentiles. You may well have seen a percentile if you've ever taken the SAT, right? Or some kind of entrance exam, they may well tell you. So you take the SAT and they give you your score. I have no idea what the SAT scores look like. 617. And they tell you that you're in the 7th percentile. You ever heard that term or seen it somewhere? Right. So what you want to do here is, what percentile is someone in, right? Given their score. Right? And then the second question is, what score would you need to be in a particular percentile? So that's turning the question on its head. So give you an example. Let's suppose we do IQs, because these are one of the simplest, nicest numbers I know. The mean is 100. Standard deviation, say, is 10. the probability that you get an IQ score, let's say greater than 113. Now I'm doing it that particular way because it's kind of back to front, but I want to do it back to front. I'm typing this in right now. So there's a mean of 100, there's a standard deviation of 10, and I want to know what percentage of people have an IQ greater than 113. And the answer comes out at about, I'm rounding this off, about 0.10. So if you imagine me drawing the normal distribution, there's the mean of 100. There's where 113 is. We have just found, well, let's put another digit in. 0.968, right? So that would be 9.68%. I'm being a little bit more accurate. That is your percentile. So you would be, very roughly, wouldn't you be in the top 10% of IQs? Right? That is a percentile. If somebody got an IQ of 117, which is basically about here, wouldn't you expect their percentile to be different? Would you expect them to be, instead of the top 9.68%, would you expect it to be even smaller than that, to be in the top 4% or top 3%? Does that seem reasonable? So, and I'm saying I'm doing this back to front, and that is correct, I am. And if you did a 117, which I'm now doing, and the answer you get is 0.045, which is about 4.5%. And we would say you were in the top 4.5%, right? So, and I should say the word top is important here. So if you got a score of 113 in an IQ test, you would be in the top 9 percentile. In this case, you would be in the top 4.5 percentile. But when you see the word percentile on its own, you actually told that guy, the white bit. So if you're in the top 9.68%, if you take that away from 100, can you see that you're in the 90.32 percentile? And if you had this one, you would be scanning all over the place. There we go, 4.5. You would be in the 95.5 percentile. So percentiles are this side. If you want to use this number, you have to stick the word top in front of it. If you're talking about something that's down here, you could say you're in the bottom 4th percentile or the top 4th percentile. But when you just use the word percentile, it always means this side here to the left. Are you okay with that? So you get your SAT and it says you're the 90th percentile. Doesn't that mean you're in the top 10%? And if you got a 4th percentile, that would be bad news. Would not make you in the bottom 4%, for instance. So you can look at it from the positive or from the negative aspect. And that's what percentiles look like. So I have, I believe it's question 12. It's to do with cholesterol, and it's women aged 30 to 39. And the mean is 205, and the standard deviation is 39. And you're being asked to find the cholesterol level such that %20 of women in this age group have a lower cholesterol. So it helps me visually. I draw a little picture and I put in here 205. We are looking for a cholesterol level, right? A number along this line here, the cholesterol levels, such that 20% of the women have a lower cholesterol. Would you agree there's some number over here where that ends up being 20% of the total? Right. Wouldn't that have to be a number less than 205? So if I screw up in my calculation, I want to know that. So how do we get that number? Basically, isn't that going to be the bottom 20th percentile, if you wanted to use that term, out of salt? Because the way we've used salt right now isn't to do that. Well, the good news is it's actually not that hard. You kind of put your information back to front. So are you looking at the normal distribution guy? So I'm going to go and I'm going to change the cholesterol level to 205. I'm going to put in here 39. And normally we put numbers in here and we pick one of them. Now I want that one, right? You see it's the same shading as my picture. So I know it's a left. And I actually, what I do is I put the answer I want here. And guess what? There's the number. Do you see how it happens? So we normally put the number in here and get the percentage, but all you do is you put the percentage here and you get the number. Right, so it's kind of using the table in a different way. So the guy I'm looking at roughly would be 172. That makes sense? Now, suppose that you worked in the medical field, and you want to decide what is a high cholesterol level or what's an extremely high cholesterol level. You might use percentiles. You might say, if you're in the top 10%, right, the really high cholesterol levels, the top 10th percentile, right? If you're up there, then you have extremely high cholesterol level. And if the doctor sees that number, or you're the nurse and you see that number because they're in bed and their blood work comes through, shouldn't that be a really warning signal? This is dangerous cholesterol level. That's maybe why they're in hospital right now, even, right? So how would you do that? Well, you've got the mean and standard deviation. If you wanted to be in the top 10%, oh, wouldn't you have to change over to the right tail to be the top, right? And you want to be in the top 10%. Anybody whose cholesterol level is 255 or bigger would be dangerously high cholesterol level, right? Now, maybe at the other end, you're interested in really low cholesterol level, right? That could be a very bad thing as well. And maybe when you do the low one, you're going to do a left tail and you're going to say 10%. And anybody who has 155 then or lower is considered to have a low cholesterol, a dangerously low cholesterol level. Do you see how this can work? Now, you might decide that 10% is bad, but 1% is, you know, take them to surgery. Something bad is packing in. Well, you could do that. You want 1%? If you have a cholesterol level lower than 114, you are in the top, you're in the bottom 1% of cholesterol level people, right? Right, so that means only about 1% of the population is going to be, you know, with that kind of cholesterol level. 1 in 100 people, if you walk down the street, would have that number. Right, so you can adjust it to anywhere that you want, and you can now find a percentile, a top percentile or a bottom percentile. And if you just want a percentile, well, suppose I want to know the 93rd percentile, then just make sure that it's a left-sided one, right? Because percentile without top or bottom mentioned is always measured from the left upwards, right? And so in this case, a cholesterol level of 262 would be the 93rd percentile. Right, I have some data I'm going to use here, but I need a volunteer who feels comfortable about sharing their height. But it has to be a, well, it doesn't have to be a male, it could be a female if I got female data.
I mean, I'm 68 inches.
68 inches. Okay, we're going to do you then. So for males, the average is 69. And was that the height? Yes, 69. And their standard deviation for American males is 2.9. And you are 68 inches, right? So,
yeah.
Well, let's find out how many Americans are your height or less, right? So that'll basically be your percentile. So if you stick a 68 in, you are in the 36th, almost, I'll round it off. You're in the 37th percentile, which means 37% of Americans are shorter than you and the rest are taller. But of course, if you have still got a couple of years growing, that may change. Are we okay with these percentile questions, Ed? You know, what cholesterol level do you need to be in the top 10%, the bottom 5%, or what is you know, the percentile for some particular person? That's going to be us as far as that work's concerned. Are we good? Last chance? Okay, we are finished with that then. Let me jump over then and spend 10 minutes or less, we'll see, on this guy, which is, what is your midterm going to look like? First thing I'm going to tell you is that I will be taking Tuesday off. I'll be using the one personal day that I'm allowed every quarter. And instead of going to Vegas or getting drunk and starting a fight, I will use that day to grade your midterm so you'll get it back quickly. And I can't teach and do that at the same time. I don't have enough time. So remember, Tuesday is off. Now, let's see if I can make this a little bit bigger. That's pretty good. And I'll move it over so you can see it. Oh, maybe you could see it all the time. Right. So there is a new module called Midterm Exam Information. When you turn up on Monday, that's actually going to be the only one you'll see. See all the other ones with the videos? They'll be gone. Right. And in here, you will find half your midterm. So let me click on this guy because he's got most of what I want to say already written. And that way you don't need to write anything, you just need to come here and look. going to be on, can I make that a little bit bigger? Yes, I can. Okay, here we go. It's going to be on Monday, as you know. It's going to last 2 hours. And it's going to be covering the first 5 weeks. So the last thing that you're going to see in the test is going to be on the normal distribution. Right, so the last question is going to be from there. Part 1 of it will be in WebAssign, and it will just look like normal homework. When you go to WebAssign, everything else will have disappeared again, and there'll only be one thing looking at you, and that one thing that's looking at you will be midterm exam. What am I going to call it? I'm going to call it midterm exam part 1, right? And that's on WebAssign. And those questions are there because you need to be able to use salt. For instance, what we did today, didn't you really need salt, right? You couldn't do that in paper. So you're going to do those questions there. I'm also going to put the multiple choice ones there. So you know the ones where they give you something and there's 4 choices and you pick the ones that are right? That's the kind of questions that are going to be there. So anything that you needed salt for, right, or you needed a multiple choice is going to be there. And you'll do that. You can do them in any order you like. You can do part 2 first and part 1 second, if that's kind of the way you want it. But let's pretend you did the midterm first. And then in Canvas, there's going to be a guy called Midterm Exam Part 2, and it's a PDF. So just like this is a PDF, when you click on it, it opens up, you scroll through it, there's questions. But those questions, you're going to show me working for. So examples of questions that would fit there. Wouldn't a lot of the probability tree questions fit there? And questions like the probability of getting a king given that it was a red card, right? Those types of questions could go there, right? So questions where you would show me working would typically belong in that group, right? And well, that's the first part. Anything that I've mentioned that you want more details on? You're comfortable it's in 2 places, right? Some of it's in WebAssign because you need to use salt and you get multiple choice there, and fewer questions probably in the PDF version, right? And those you can show me working for. And the advantage for you is that I can see working in part 2, and you need to show me you're working, because then I can at least see if you got the wrong answer, where you're doing it the right way. You know, if you do one of those probability trees, say if you screw up one of the numbers, doesn't the whole answer end up being wrong, even although you put a 0.3 when you meant to put a 0.6, right? Whatever it is. But if I see that you're building it correctly and you're using it in the correct way, then you don't lose all the points, right? You get a lot of credit. Okay, there are going to be 2 slots. You get 2 hours, 7 till 9, or you can do it 8 till 10. If none of those slots work for you, you have to talk to me. And there is a 3rd time slot, 7 till 9 p.m. So somewhere in there, you should be able to make it. Okay. When you turn up, whether you're doing the WebAssign part or whether you're doing the PDF part, I need to see you, because that's the security that there's no cheating. So you need to get your webcam and you need to have it on so I can see you. You can use your phone, for instance. Right? That can be done if you don't have a computer webcam, but I need to see it. Anything about that a problem? Are you comfortable? You know when you're going to do it, and you've got time slots. You pick the one you want. You turn up when you want, and I'll see you, and you'll be good to go. Now, the responses, the working for part 2, you'll be writing it down on paper, and I want you to show all the working so I can give you partial credit. You don't show working for the midterm part 1. Do you know the ones that are in Canvas? I don't need to see working. There's no actually much point in you showing me working. And don't you just hit salt and put in the buttons and you get the answer, right? But the part 2, show me working. So when you've completed part 2, I need to see your working, which means you're going to have to upload it And I've got a program called Microsoft Lens, which I'll talk about in a little while, which basically you take pictures, convert them to PDFs, and you upload it. But you can use any program, including scanning it in your printer, right? But I got to get, I've got to physically get your working in a format that I can now read. You can't show me it by holding it up to the screen. That ain't practical, right? So I need to see it. And when you've done that, you're going to upload it into an assignment called, there's its name, so you know what it is. And that will be in that module, right? Everything you need will be in that one module. Right?
Do we have to do this in like the time slots, like within the 8 to 10 a.m.
No.
or is this like
What's
anytime
going
throughout the day?
Yeah, you shouldn't need 2 hours, but if you did use every one of those 2 hours up, you would tell me you were finished, and you get about 5-10 minutes to upload it, right? It doesn't take more than that. And so,
cool.
Yeah, you can, if you get really pushed for time. I'm trying to make sure that that's not an issue. Just share this. The way I normally time exams is I do it myself in paper, or if it's salt, and then I double it. So if I can do it in 30 minutes, you should be able to do it in an hour, right? Because I know it's a little bit better, perhaps. So nobody should be. Most people shouldn't have a time issue. Right. Now, the Zoom link that we are going to use is this Zoom link. Right, so don't use your normal class Zoom link. This is a different one because it lasts different, and there's going to be people coming in from other classes because there's overlaps in times. So that's the one that you will use. Any questions at this point?
Is this on Canvas, this paper here?
Yes. So I'll show you where it is. Home. It's in midterm exam information, and it's called, right at the top, Math 146. Right. Now, here, I've put another link to that same thing. So that's just overkill, right? It's the same Zoom link that's in the first thing, right? Here's practice, which I know some of you have actually printed out and looked at. You remember this, guys? That's just to give you a kind of feel for how questions look and, solutions to them. That's just a resource. That is not an assignment that you need to do. Right. We talked about how to get your working to me, right? How to upload it into Canvas. So you click on this guy, and if you use an Android phone, you use this one. If you use an Apple device, you use this one. And here is a video, which, there we go, basically takes you through the whole process. So how to, I know they've got budgeting, but just think of that piece of paper as your working, right? And do it like that. I lost my train of thought here. So get practice at doing that, because I don't want you to turn up on the day of the midterm and say, I don't know how to make the thing work. I've just closed that by accident. I've put a little dummy version in here. Right, here we go. Can you see Canvas again, or will I have to go out and in? So I'll do this thing. Are you looking at Canvas still? Okay, so do some practice. Click on this practice upload working here. So you've taken pictures of some doodles, whatever it is you've taken pictures of, just something to practice with. You've used it, you've saved it as a PDF, just like the video told you. Hit that guy. If you've saved it somewhere, like on your phone or computer, if you're in Canvas with your phone, then you can do it that way. You can save it to OneDrive if you feel like it and get it there. If I click on that and I go choose a file, I could choose, well, let's choose something that's not personal. Academic calendar will do. You will have called yours something like John Smith's midterm, right? give it a name that's easy to remember. And then you just say submit assignment. Right. That took about a minute, right? So after you've got your PDF, doesn't it take very little time to upload it and you're done? Now, when you're finished doing it, come back or don't leave. But if you might have to come back because one person said, look, I have to switch off my phone to do this because I only have one source. But come back and ask me, is it there? Because one of the things can happen is that you think you've uploaded it and then I go and look at it and it's white on white because you didn't do a very good job of contrast and I can't read it. And I'll say, no, it didn't work. Could you darken it a little bit or change where you take the picture? I found it's best when you don't have sunlight at your back. Have you ever noticed you take sunlight at your back, all you get is very poor quality pictures because the sunlight is reflecting off the thing. So that would be me. And once that's done, you have Tuesday off to recover. And then when I see you on Wednesday, we'll start the next topic and I will have your final, not final, but your midterm report. That will include all homework, everything, including your midterm. So that'll be a good indication of how you're doing in the class, because that's essentially us halfway through. Any more questions? I think we did perfect timing. Last name for attendance and bye-bye. And I'll hang about if there's any other questions.
I have a question.
Yes. What is it?
So I have time and a half. Do I need to email you separately?
No, Skylar, you will be just turning up to one of those time slots, but adding an extra hour to the end of it. So that's all. And again, I don't think you'll use it all, but it's there if you need it.
Okay, that's good. And then also, do I need to let you know what time slot I'm coming to?
No, because you will turn up and I will see you, so I will know what time slot it is.
Okay, that sounds good.
Okay.
Thank you. Have a great day. Have a good weekend.
You too. Bye-bye.